So today I've been given two functions and I've been asked to find the inverse and graph the inverse. So let's talk about what an inverse function is. An inverse function is when you swap your independent and your dependent variables. And the reason it's important for us to find inverse functions is because if I know the inverse of a function, the two have a canceling effect. In other words, if I have this particular function and I have its inverse function, the two will cancel each other out. And that's pretty useful information in mathematics. So what I want to do is first just start with a simple equation. This is the equation of a line. And the easiest way to find the inverse of a function is first rewrite this not in function notation. Okay? So y equals 3x minus 8. That's the first step. Rewrite it not in function notation. The second step is to swap x and y. Swap your independent and dependent variables. So we get x equals 3y minus 8. Third step is to solve for y. Okay, so add 8 to both sides. We get x plus 8 equals 3y. Divide both sides by 3. And we get x over 3 plus 8 over 3 equals y. Now, because this is my inverse function, I'm going to put this back in function notation. However, I cannot call it f of x because f of x is the original function. This is a different function. So because it's the inverse, we're going to use a little math notation. We're going to call it f inverse of x. So whenever you see this f and this exponent of minus 1, that means it's an inverse. So f inverse of x equals x over 3 plus 8 over 3. So this is, ta-da, our inverse function. Okay? So now what I want to do is I want to graph these two functions on a sheet of graph paper to the best of my ability, and then come back and I'll show you something interesting. So anyway, we've got our graph paper here. I'll zoom out just a little bit. So here's our graph paper. And I've taken the liberty of drawing a line on here already. This line is y equals x. It's a 45-degree line that goes across the paper. And I'm going to graph our two functions. Our first function's a real simple line, f of x, or y, equals 3x minus 8. So the y-intercept is at minus 8, and the slope is 3. So I'm going to go down to minus 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And I'm going to go up 3 and over 1. Up 3 and over 1. Up 3 and over 1. As many times as I feel the need to. Okay. And then draw a line. Okay. So I'm going to take, I just have this smoky triangle here that's I like to use for graphing. And I'm going to draw a line that goes through these points. Okay, so this is y equals 3x minus 8. Okay, so this is y equals 3x minus 8. Okay, now I'm going to graph the second line. And of course, I've chosen a function out of some random book of mine that doesn't come out to nice numbers, but it's close enough. 8 over 3 is almost 3. It's 2 2/3. So I'm going to remind you of that. Our inverse function is 8 over 3. The y-intercept is 8 over 3. And the slope is 1/3. Okay, so the slope is 1/3. And the y-intercept is 8 over 3, or 2 2/3. So I'm going to go up 1, 2. I'm going to go up basically 2 2/3. Basically somewhere about right there. Okay? And I'm going to go up 1 and over 3. Up 1 and over 1, 2, 3. Something like that. Up 1 and over 1, 2, 3. Something like that. Up 1 and over 1, 2, 3. Something about like that. Okay? Now, why are we doing this? Well, as I graph this, I'll explain why we're doing this. The properties of inverse functions, one of the things that they tend to do is they tend to cancel each other out. Now what that means geometrically is that this 45-degree line here, this y equals x 45-degree line, has a slope of 1. What that means is that this slope and this slope will cancel each other out with a slope of 1. Well, when we, if I said to you, what is 5 divided by 5, you'd say they cancel out. And if I ask you, what number do they equal? 5 divided by 5 equals 1. X divided by x equals 1. So, when we say something quote unquote cancels out, with multiplication and division, we really get a result of 1. Now, why is this important? Well, some of you may see it already. But if I take this paper and I fold it along this line, these two pieces here will lay on top of each other, and these two pieces here will lay on top of each other. Okay? So I'm going to do that real quickly, just try and fold my paper. And I don't know if you guys can see that dashed line through the paper. It's kind of hard to see. But basically what I'm trying to do is fold this, and I made the line pretty deep so that I could cheat in folding. That's a trick, by the way, is you take a ballpoint pen and you bear down very hard on the graph paper, and it leaves a nice crease to fold on. And so what happens is, if you look, now that I've got it folded on this line, if I fold it over, you see the two lines lay on top of each other. Okay? And over here, the two lines lay basically on top of each other. You can see I missed just a little bit. But those are mathematical inverses. And you say, well, what about my TI-84 or my HP-49 or my Casio, whatever type of graphing calculator you've got? Well, I've got my TI-84 handy. And I'm in the wrong mode here, of course. And I go to y equals, and I say, okay, I want to graph my two lines. Let's remember what our equations were. Our original line was y equals 3x minus 8. So y equals 3x minus 8. And my second line was y equals x over 3 plus 8 over 3. And I graph those, and I'll see that these two lines meet and look very similar to, I don't have the same window you guys have. I'll zoom out. By the way, a real quick, easy way to get to this window is if you hit the zoom key. Option number 6 is zoom standard, so you just press 6 and it'll zoom to a 20 by 20 window. And so you can see a very similar graph to what I have on the graph paper. And if you want to see the 45-degree line, that is the equation y equals x. And so you can see that third line, and you can see that these two this piece and this piece would fold on top of each other, and this piece would fold on top of each other. So kind of a fun way to see this on your calculator. Now, move on to the second question here. My second question says f of x equals square root of x plus 4 minus 2. And again, I've been asked to find the inverse and graph it. So the first step is to find the inverse. We'll define the inverse. We write it not in function notation. And then swap x and y. So x equals square root of y plus 4 minus 2. Okay. Add 2 to both sides. So we get x plus 2 equals the square root of y plus 4. We'll have to get rid of this radical. So to get rid of this radical, I'm going to square both sides of this equation. The right-hand side becomes y plus 4. Simple. The left-hand side will become x squared plus 4x plus 4. And please be careful to note something. I'm going to write this in a different color. This is very, very, very important in mathematics. X plus 2 squared does not equal x squared plus 2 squared. Okay? you have always a middle term. When you have a quantity squared like this, you're going to have three terms. You're going to have two end terms, which is x squared and 2 squared, and then you're going to have a middle term, okay? So be very careful of that. Just kind of a little note for you. Now, back to what we've got here. We have to solve this for y, so our last step will be to subtract 4 from both sides. When we do that, we get y equals x squared plus 4x, okay? And then our last step, of course, is to put this back in function notation and to call it the inverse. So f inverse of x equals x squared plus 4x. Now, so this is our inverse function. Now, we have a minor problem here. If you look at your original function has a domain restriction. What does that mean? Well, anything that makes this radical negative will give us an imaginary result, which we cannot graph on the real plane. So we look at this, and I immediately know that x must be greater than or equal to -4. Okay, I immediately know that. Now, how do I know that? Well, -4 plus 4 gives me 0. Anything smaller than -4 will make this quantity here negative, which will make the original equation imaginary. And I don't want that. So x has to be greater than -4. Well, in finding the inverse, I swapped x and y. And when I swapped x and y, I swapped the domain and the range. So if the original equation has a domain restriction, the new equation will have an equivalent range restriction, okay? An equivalent range restriction, okay? So, now, let's take a look. Let's take a look. So I've got these two equations, and I want to graph them, okay? And I've got my handy-dandy, wonderful little piece of graph paper here. And the easiest way to graph, now these are both going to be curves. I've got x squared of x plus 4 minus 2, and I've got x squared plus 4x. These are both going to be curves. And the easiest way to do that is, of course, to have a table of numbers handy. And so what I'm going to do is I'm going to cheat. I'm going to use my TI-84 to generate some numbers and graph this by hand because I can't fold my calculator screen. So I'm going to type square root of x plus 4. You've got to remember to close your parentheses, and then minus 2. And then I'm going to type x squared plus 4x. And I'm going to go to my table, and I say, here's the problem. Look at my table, 0, 15, 30. It's set up wrong. So I go to table set, which is right above the window key. I want my table to start at 0, and I want my table, delta table, to be 1. Go back to the table, and I see this. Now, what this tells me is the first function, which is the square root of x, here are the y values as x is 1, 2, 3, 4, etc., etc., etc. So what I'm going to do is I'm going to try to graph the values in the center column here, which is x is 0, y is 0, x is 1, y is 1, x is 2, x is 3, y is that, etc., etc., etc. And actually, I'm going to start for, now you notice I get an error, because what did we say about that equation? We said that for the square root of x plus 4, right, for this square root of x plus 4 minus 2, x had to be greater than -4. If you go to anything bigger than -4, what do you get? You get an error. So I'm going to start at -4, -2, and work my way forward, okay? So I've got this table. I'm just going to set it to the side, and I'm going to graph these points and show you what I get. So my points are as follows. For the square root of x plus 4 minus 2, I'm going to get -4, -2, and I'm going to get -3 and -1, and -2, and I get negative 0.58, so that's going to be about half. And then negative 1 and 0.26, and then 0, 0, and then 1 and 0.23, so somewhere like that. And really, I'm just guessing. You have to do your best here. 2 and 0.44, so that's a little less than half. 3 and 0.65, so that's a little less than 3/4. 4 and 0.82, so you see I'm just very slowly. And then 5 and 1, okay, and on and on and on and on and on. And let's see, my next one, I'll pick 8 and 1.46, which is about 1.5. And what I'm going to do is I'm just going to try and connect these dots, because as you can see, this is going to become rather unwieldy, because these little points get very, 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 very close to being almost not changing at all. And your goal here is that this looks smooth. Okay, you trying to get a curve here, not some weird, jagged straight line. Okay, so it's going to look something like that. That is the graph. This is y equals the square root of, oops, a little heavy-handed there, x plus 4 minus 2. That's the graph that we've got there. Now, I'm going to graph the other one by hand. The other one I have is a quadratic, and I'm going to start at x equals negative 8. Okay, x equals negative 8. And at x equals negative 8, y equals 32. At negative 7 is 21. At x equals negative 6, I get a y value of 12. So something like that way up here. At negative 5, I get a value of 5. At negative 4, I get a value of negative 2. So 1, 2, 3, 4, and negative, go figure. Excuse me, a value of 0. Reading the wrong column here, that would help, wouldn't it? At x equals negative 3, I get a value of negative 3. At x equals negative 2, I get a value of negative 4. Okay. At x equals negative 1, I get a value of negative 3. At x equals 0, I get a value of 0. At x equals 1, I get a value of 5. At x equals 2, I get a value of 12. And this very quickly will go off the page. And so I come in here, and again, I'm trying to graph a very smooth curve. And that side doesn't really matter, so I'm not going to spend a lot of time on it. What do you mean that side doesn't matter, Mr. Murphy? Well, I'll show you in a minute. So I'm trying to graph a nice, neat parabola here. And it's not as easy as it looks, I promise. And if you don't believe me, you try it. And so I get something that looks sort of like that. Okay, so I get my nice, neat parabola. Now, what's the problem? If I fold my paper right now, do these two graphs look like they would lay on top of each other? No. This has two curvy legs. This has one curvy leg. Something is wrong. And that something is that this has a domain restriction. Therefore, this has a range restriction. Well, the problem is, what's the low point on the parabola? The low point on the parabola is y equals negative 4. Well, both sides are greater than negative 4. That doesn't help me. Well, the trick here is really simple, folks. If you look, which side of this parabola matches this function, and it's from this point forward. So this point, -4 on the y-axis, corresponds to a domain restriction of -2 on the x-axis. What that means is everything to the left of the vertex cannot exist if we want these two to overlap. So because the original problem had a domain restriction, the new problem will have a range restriction, which leads to a domain restriction of, let's write it down, which leads to a domain restriction of x greater than or equal to -2. Okay? Which I have done. Now, what do we see? These look like inverse functions. They look symmetric about this 45-degree line. Again, I'm going to take my graph paper and I'm going to fold my graph paper. I took my ballpoint pen and I pressed down very hard on these lines, and so it's very easy to fold if you do that. And just, boring, you're watching me fold paper. It's like origami class, okay? There's actually some really cool stuff they do in origami nowadays, but that's beside the point. So, and if I take these two and I say, okay, well, there's my folded line, and I fold this over, what do we see? Can you see that the parabola and the square root equation are laying on top of each other? The parabola and the square root equation are laying on top of each other. And I did a pretty good job drawing those because they match up pretty well. So, so just kind of a fun thing to see that those two lines lay on top of each other. There, you see it right here, barely through the paper. The two lines lay on top of each other if you fold the paper. So there's my graph. Now, obviously, I could graph these a lot easier on my TI-84 by simply doing that and then that. Oh, oops, problem. Those don't look like inverses, do they? The way to correct that is to go to your second equation and add a domain restriction. The way you add a domain restriction is you put the original equation in parentheses, and then right next to that you put the domain restriction in parentheses. Well, I want x to be greater than or equal to -2, so I click X, and the greater than or equal to is in the test menu that's above the math button. I'll zoom in so you can see the test button. See there above the math keys, it says test. You press second and test, and you'll see these symbols here. You want greater than or equal to -2. Close that parentheses and then graph again. And what it does is it only allows it to graph from x equals -2 and forward. And then I can add my third line, which is y equals x. And we see here's the graph with our technology. And here's the same graph on just a good old-fashioned sheet of graph paper. And so that's how you find inverses and graph inverses and verify inverses graphically. And so I hope that's a fun little lesson in inverses. And if you have any questions, please let me know.